Okay, so Leetcode practice time. So binary tree right side view. Two goals. The first one, of course, is to see how to solve this problem, to find the solution, and then we are going to put in some solid code to solve this specific problem. And the other one is to see how to behave during a interview. So let's get started. During interview, there are a few things to do. The first step is always to understand the problem. Try to fully understand the problem before you proceed to the next step. If you definitely have any question, please ask the clarification questions. And also think about some edge cases that can potentially break things, which is pretty special as the input. And also after that, it will be like we find the solution for the specific problem, communicate with your interviewer, and do some runtime space analysis, and then get an agreement with your interviewer before you proceed to the next step to do some coding. In coding part, we care about your code correctness and your code readability, and also the speed as well. So in this part, we mainly test the ability for you to turn the idea into solid code. And the last part is about testing. So after you're done with the code, you need to set up some test cases. So maybe go through one of the test cases manually to do some sanity check. And also think about some edge cases and bring them up in the interview. Try to increase the test coverage by setting up those test cases. So let's use this example question here. It's actually not an example question, I think. Okay, so Facebook, Amazon have used the question during the last months in real interviews. So let's see. First step, try to understand the question. So given a binary tree, imagine yourself standing on the right side of it and return the values of the nodes you can see ordered from top to the bottom. So let's say the input is something like this, and the output is gonna be 1, 3, 4, which is a right side view. So okay, so I think that's pretty clear. I would say one edge case is suppose the root given to us is empty, then that's definitely a edge case. If it is a non-pointer, if the root node is a non-pointer, then we simply return an empty output list. So let's see. So the definition for a binary tree node, of course, it has a value, it has a left reference, right reference, and it defines the constructors, some constructors here. Okay. So I think we are done to clarify the question. We have fully understand the question, and we saw the edge case would be a empty would be a non-pointer. So I would say if root is a non-pointer, then we simply return a empty list, new select list. Alright, so the next thing is about finding solutions. So how to solve this problem? So usually for this kind of problem, I would say BFS seems to be a very good fit. So it's called BFS, buffer search. So the thing is like this: we maintain a queue in BFS, and we keep pushing the left child and the right child of the current node into the queue, and every time we also pop the first inserted element from the queue, and if it is the end of one layer, we definitely put it into the final result. So I think this one, the runtime is going to be n O of n. N is the number of nodes within the tree, and the value is, the space wise, so the space, it is going to be, I would say in this case, it's actually the size of the layer that contains the most node. So in this way, I would say it is still, so the first layer is 1 and the second layer is 2. If it's a full tree, then that layer is, then the third layer is 4, so on and so forth. So let's see. So if we put so each layer is 2 to the power, if it's a full tree, it will contain 2 to the power of level -1. So then I would say the space-wise is also going to be all of n. So if it is a full tree, we may need to store all the nodes from the last layer, which is about the same size as of n. Okay, so let's give it a shot to do some coding work. So first of all, we are going to define a queue, not integer. It should be tree node. It is a queue, and we use a linked list as the underlying implementation for the queue interface. Alright, so first of all, we are going to put root into the queue, and well, queue, not queue dot empty, okay. We are going to see the size of the current layer. So int current layer size is equal to queue dot size. Okay. So we are going to iterate through the current layer. Okay. So actually, we also need to define a result list. Let's say if it is the right side view, let's say it's the right view, and we use a new linked list. Okay, so in this for loop, we are going to go from the first node until the last node in this layer. I is smaller than current layer size, and the plus I. So if I is equal to current layer size -1, then that's the time we are going to push the number into the right view. So we are going to have right view dot add. Okay, so it is so this one, we need to have the tree node actually popped. It's equal to queue dot remove. Okay, we are going to add the value from the last node into the right view here. And here we also need to push the left node if it is left child, if it's not none. If node.left is not a non-pointer, if it is a non-reference, then we are going to push it into the queue. And the same for the right child. So dot add node dot right. Alright, so that's it for this BFS implementation. Finally, we need to return right view. So that's pretty much it about the code. And remember, after coding is not done, we still need to do some testing on top of it. So let's use this example. Let's say by going over this input example, let's say first of all we are going to push the root node, which is 1, into this queue and step into this while loop. So the current layer size is equal to 1. So here we are going to remove the root node from it, and currently I is equal to the last node within the first layer. So we are going to put 1 into the right view list. And since the left child is not none, we are going to put 2 into the queue and 3 as well into the queue. And then this is the end of this for loop, and we step into this while loop. The current layer size is equal to 2, and we are going to put 3 when I is into the right view when I is equal to 1, so on and so forth. Okay, I think it should be pretty correct. Okay, so Q cannot find symbol, so Q not empty. Okay, so I guess this interface doesn't give us the empty function, I guess. It's not equal to 0. Let's say this one. Okay, so now it is correct. Let's do a submission. Okay, so now it is accepted by this platform. So I would say definitely set up a task case which is non-pointer for the root, and otherwise set up some example like the example given here, and then I would say the task case would be good enough to cover most of the branches. The test coverage would look pretty good to me. So that's it for this coding question. I hope you enjoy it, and thanks for watching. If you like it, please give me a thumb up, and I'll see you next time.